Check, check. We have sound. Hey, welcome to the Programming Games Club. Well, my name's Blades, and yeah, we're back. Not feeling very well, but hey ho, we'll see how long it'll last. Let's get rid of that. Let's find out how up to date we are. We're doing magic numbers today and tidying up past one on Vulcan renderer. Okay. So I think I know what I'm doing. What the heck's on this page then? Qt Vulcan graphics, the widget, the system, first model, all of that. Yeah, that's all on here. So yeah, we'll do magic numbers from here, I think. Okay. Interesting. Right, let's just update. Manage videos. We did do a video the other day. Alright, that's on its way up. Let's add it to the playlist. Good. Done. Refresh. Check the playlist, make sure it's in the right place. Nothing. Okay, that didn't work. Okay. Refresh. That's better. That makes sense now. Right, that'll do itself automatically. Eventually. It'll get there. Magic numbers, what the heck are they? Well, let's see if we put a definition up. Constants which should be variables. That's a magic number. Basically what we've done is in pass 1 on our Vulcan renderer, we've put some magic numbers in to make it work. But those numbers shouldn't be constant. They should be variables. Because we are defining our data. And our data, as we're going to find out very soon, is going to change. Hello, viewer. Good to see you along. Oh, and a shout out to Tariest Python. Thank you for the follow 2 days ago. I don't forget. I read the screen. Oh, that's not good. Why is that happening? Something's not right there. Great. So I think we'll just dive in, find out what the heck's wrong with this program. I mean, pass 1 is just garbage code. Let's be honest. Ah, no signal. Better switch the machine on. There we go. Got a keyboard. Let's have a mouse. Okay, we've got a mouse. Get everything else out of the way with. Get off the screen, you. Thank you. Move that so can see chat. I was thinking about putting it all onto this machine. So I could pull chat up and see it. And we should have nothing. Oh. Oh, alright then. Apply. We'll get that done before we start. Oh dear. Oh, disabled a couple of keys. Interesting. Hope they weren't in use. Yes, they were. Oh dear. Never mind. Do I honestly care? No. What changes have I made? Five changes. Those are logs. All right. Start for stream. Magic numbers. Commit changes. Done. Push them all up to GitHub. There we go. So anybody who doesn't know, if we hop over to GitHub, here, there's Fraser Blade Sharp. There we go. Fraser Blade Sharp's runner. If you're on main, you're in the wrong place because I'm using GFX dev. And if we view the code, you'll just see that magic numbers has come up. Start of stream magic numbers 36 seconds ago, and everything's up to date. So all the code is here. It's exactly the same as what I've got here. And I am going to use which one? Well, we were doing convert to Blender. I don't think I want to touch this one. No, let's not touch this one. Because it's working. I think it's working. Yeah, that's working. So we'll close that. So Vulcan render is the one that I was messing around with. Good. That's the one we'll carry on messing around with then. Namespace night. Alright. So, how do you work out which constants are variable and how do you deal with it? Well, first of all, you've got to find them. And we have, that's buffers.h. No, don't want this place. We'll just close everything. We're dealing with the renderer. I only want one file, this file. We're dealing with around 1,200 lines of code. But there's a lot of spaces in, so it's not really that big. It's about half that size, if that. We've got a couple of statics, so I'll go for here then. So I'm just going to list them out here at the top so I can see what they are and decide what to do with them after. Come on then. Hello Poppy. How are you doing? I think that's a good place to start. Oh dear. What's wrong with this lighter? Interesting. Okay. Got to fix my lighter in a minute or two. That might help. So we've got things like this. Is that a constant or a variable? What does it mean, 16? Well, funnily enough, that number there is the size of a matrix, which is 4 floats by 4 floats, 16 floats. And the uniform data that we're sending through to the shaders is a uniform map4 matrix 4 by 4 16. So that is the number of floats in a matrix. Is that the only kind of uniform data that we would have? Just a single matrix? Well, the answer to that is no, obviously. There's other uniform data that we could use, and this could become different. So this can vary depending on this. If we change our vertex shader, why is that wrong? Is that wrong? It's not wrong, it's just underlined. Should there be a U there? Yeah. According to this, there should. I'll keep that. We'll see how that works out. So this can be extended to contain more things. So it's variable. The whole layout is variable, so anything that's one of these is a variable. We can add more locations. In fact, we have to add more locations if we want textures. Alright, so that is the size of a map 4. So, we found one on line 1. How am I going to approach this? I'm just going to put in hash define and then I'm going to put in capitals num floats in matrix. So I'm going to describe what it is, and then I'm going to put the answer. So now this describes what it is, rather than just being a constant. Because we might have to add to that, so we might need a plus sign there. I'll also put that onto the next line. There we go. So it reads downwards, so it's easy to add to now. We can add a plus. So we can add to our uniform data quite easily. Right, so with that one, -1s, they are constants. They're not variable. Our code seems to be going off the right hand side somewhat here. So let's stop it from doing that. Hold on. I haven't done any of these, have I? Hold on. Okay, we have constants here. What do they mean? These are sample counts, but these are being used for choices, choosing. I think they are constants. I don't think they vary. I don't think we're ever going to get to 32. Well, we're on 64-bit now though, aren't we? No, the graphics card's still on 32. So the maximum sample size is 16. Yeah, okay. Yeah, graphics cards are still 32-bit. Well, there you go. If it was 64-bit, then we'd need a 32 as well. Interesting. Okay, then we've got all of this garbage. We're not in pass 2, so that's an instruction to be done later. It's also wrong. Fantastic. Nothing wrong with that bit. And this timer, 1 second, that's a constant. I'm just thinking, should we really have a constant there for a second? Not really. But it is a constant and it hasn't been noted as one, so we will put a note in. So just a note to ourselves so we don't forget what that line's about. That's your FPS calculator. And of course FPS is frames per second. So that's why that's 1 second. Not really hard to understand, is it? Okay. Now you can see the problem with these constants. If you want to change any of them, well, we can change this one now. Quite easily, it's at the top. And we know what it is. That will probably never change, but we may need to do things extra. In fact, we will have to do things extra because we're going to do lighting as well. That'll be interesting. I'm dreading the next bit, which is textures. Have you ever done textures in Vulcan? Ooh, could be fun. Could be fun. So the only way to find these constants is you can't do a search because they're just numbers. And you don't know what numbers they're going to be. So you can't search. The only way to find these magic numbers is to look at the code. And this is why we're doing it now. Because this code is going to grow. Yeah, there's more code to add to it yet. There's textures to add. Oh, we've got a 0 here. That's a mem set. That 0 is just nulling the mem. Why are we doing that? We don't need a mem set there. This is past 2 stuff. Doesn't matter then. This is what I said about this is rubbish code. Anybody who knows anything about C will spot entirely why we don't need a mem set. Why this person who wrote this piece of code as an example kept putting mem sets in, I don't know. I've got a feeling they were a C++ programmer who didn't know C, or thought they knew enough about C that they needed a mem set. You don't. Oh well, we'll get to that, I guess. No, I'll show you what I mean. If you put that equal to nothing, it will automatically zero out everything within buffer info. Buffer info is a struct, a structure full of variables. That says create a struct full of variables and put them equal to 0. That gets rid of that. And the first thing in that buffer info is its S type in that struct. Let's go and have a look. So here's the structure. And the first thing is S type. So everything in here has been set to 0 because we've got 2 brackets. Also, S type is the first thing in all of them. And it's done on purpose. It's been placed as the first thing in all of them on purpose. So that can go in the brackets. Because it's the first thing. And because we don't define any of the other things, they all get set to 0. Well, that saved a few lines of code, didn't it? Now, the person who wrote the initial example should have known that. 100%. But they didn't do it. Why? Is that a lack of knowledge? Missing field. Is that because you get this missing field thing? That's interesting. Now, why does that come up here when it's C? Have they changed something? What it's saying is that it wants comma 0. And it'll still say missing field because now it continues. Wow. So I didn't know they'd done that. Okay, so that's not compliant. That is compliant. That's interesting. We'll keep it compliant with C and C++. Don't want to break the rules and get warnings. So if I was programming in C without C++, I would place that in there. But because we've got C++ involved, we can't. Wow. Okay. Why do we have a uint64 here? Allocate size. Device size. Got a feeling that's how much memory we've got available to us. It's looking that way. Float, yeah. Align. No, that's the allocation size for our data model. How much memory on the graphics GPU we wish to use, and that's dependent upon the model data, the 3D model data. Well, that makes sense. A uint64, why not a 32? You see, our GPU is 32-bit, so why are we using a 64-bit unsigned integer to measure the size? Because we can. I think that is a because we can. So we allocate it, yeah. Then we calculate the full buffer size and what the buffer is going to be used for. So vertex and uniform. Yeah, we're just using a single buffer instead of 2 buffers. That's fine. La 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 la. Very easy to understand all of this. Then we have memory allocation using Vulcan memory allocator. Oh dear, now we come to some... oh wait a minute, we've got one here. What's this 0 mean? Bind. What? Memory offset. Hold on a minute. That comes from VK device size, memory offset. Weren't we just looking at that? Which one? We've got two. Well, it's both. Buffer info size. Well, it's 0 because we want to start at the beginning. Ah. I wonder if it's in the buffer info. Any offsets? No. So it is what I expected it to be. I shouldn't do that, I should do it that way. So we've got a 0 here that is not necessarily correct. It could be different. It's a variable. I know it's a variable because it's being asked for by this. So it's actually two buffers. It's that one. We need the offset for that one. And I bet you anything, there's nothing there. Where's the structure gone? It's gone there. Ah. So we can't use that one because it's been overwritten. No, it hasn't. Yes, it has. No, it hasn't. Why is Vertex allocation size not accessible? What have they done? That's because it's a type def to a uint64. It doesn't exist. So the variable isn't there. Okay. And that's why that's a uint64. Right, got you. Oh well. All I can do is note it. Or what happens if I want to start or use a different part of the memory? I would need to change that, wouldn't I? I don't know what to do with that one. It's a magic number, alright. It's buffer memory, and it's an offset. is buffer memory offset. Now you might think there's no reason for it not to be 0, but there's major reasons for it not to be 0. What happens if we don't want to draw the first model in the buffer? Or we want to choose which model in the buffer we draw? Then the offset becomes very, very, very important. All of a sudden that offset gives us the key to being able to control what is drawn to the screen. And it's all in that one number. We should have marked this. Don't need that anymore. There you go, that's 0 now. But we now know there's a magic number there, and we can find it. We can do a search and find on that magic number and find it without having to scroll through, just like what I was doing there. Oh my god, what's going on here? Again, there's brackets, so these are variables. VK map memory. What do we have? We have a device, the memory. We've got this device size offset again. That says memory offset. This isn't, this is just an offset. So it's worded differently. Are the two things equal? Yeah, this is a problem with magic numbers, you see. We've quite happily typed, well, somebody's quite happily typed them all in. Thank you to the person who gave us the example. Right, what's the second one? Mem required size. Then we've got flags. Memory map flags. Okay, I think we can do that one. I don't think we can change that one, because that's just an offset. VK device size offset. I think it's the same number, you know. I'm tempted to do that. I really am, because those two should match each other if I'm right. And this is simple. We can do that one quite easily. Memory map flags. Okay, we're at 207. Let's just mark it. 270, sorry. Okay. Hash define. Memory. You can see what I'm doing now, can't you? Map flags. We're going to have 0 with them. It's not quite true though, is it? It doesn't show me blop. Never mind, I can see it in the margin. There we go. Yep, that worked. Right, so now we know what all of these are. Those are not constant. Those are constants, they're not variable. Because that's an address. Even though it's being... the whole thing is a variable. So the constants are constants within a variable. That's fine. And again, uint64 used. Hey, look what we've got here. We've got that magic number 16 again. What's it doing? Why have we got a mem set? Mem copies. Oh, well, I don't know what that one's for. That's putting our data onto the GPU. What's this one doing? Uniform buffer. So this is to do with the uniform buffer. Well, we've already got something for that. Haven't we? That's our uniform. Plus the offset, yeah. The identity matrix, constant data, num floats in matrix, times size of a float, that's correct. You see, previously, we didn't know that these were related. But now we do. That's even more interesting thing about magic numbers. They can be related to each other. So let's bring this memory copy into perspective, shall we? Okay, plus offset. Yep, that's okay. Da 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 da. Times that. And that 1, 2, 3, 4, 5, 6, 7, 8. There we go. That's a mem copy, so we can just read it properly. Lovely. So we now know that that's related. Ooh, this is where it gets awful. Binding. What's this first number? The reason why this starts getting nasty here is because it changes depending on the VK thing that you use. There's two different ways of doing this. So it just says it's binding. So vertex binding description. You see how it's location then binding here? They really should have said binding and then location. Those two are the wrong way round. So whoever wrote this piece of Vulcan core.h, you got it wrong. Just thought I'd tell you. Just throw it out there. You should have put the binding first, because you put it first here. Programmers, You just can't pay them enough money, can you? Yeah, well, not my problem. I didn't write it. I've just got to work with whatever rubbish they give me. So that just says it's a binding. It's not always 0. Binding what? That's the buffer to bind. Is it a buffer though? Or is it a VBO? Is this a vertex buffer object? I don't know. This is where the problem starts, because there's no definition for that. It just says binding. I know what that is. That one's easy. Let's do this one. This is the number of floats per vertex. So let's add this one in. So let's make a definition for this. Num floats per vertex. Currently is 8. We have 4 floats for the position and 4 floats for the colour. So that's 8. It's not hard to work out. Yeah, that's now 8. See how the binding went second here? Ah, dear. These are variables. That binding is a variable to what? Binding what? Why has it got a 3 in brackets? Binding is the binding number that this structure describes. Binding must be less than the max vertex input bindings. So this is vertex input bindings. What does that mean? Are we on pipeline or just... No, we're not. And then it just goes on to the next one, which is been written incorrectly. Fantastic. is the binding number which this attribute takes its data from. So it's the buffer binding. It's the buffer binding handle, because it's just a straight number. It's like OpenGL uses handles. It uses a lookup table on the GPU for the buffers, and this is 0th buffer in that table, and that will hold the address for it on the GPU. Gotcha. So it's the buffer binding handle. I will go with that because I understand what that means. Buffer bind handle. Well, it's the buffer handle, just like it is in OpenGL. So we'll take that. That can go back down here now. Trying to make sense of all of this rubbish. That's now that. We don't need that anymore because it tells us what it is. And it goes there as well. It's the same number. So it's used twice. Don't need that because we know what it is. Location in shader. Which means this location in the shader. That number there. So that's position. Shader position location. This is to do with shaders, isn't it? So let's put this here. So I've got shader position location 0. And we have, what else have we got here in our shader? Color. So hash define shader color location, and that equals 1. Then we should have the uniforms location. Do we not have a uniform location? Not really. Should we have a uniform location? No, it's a binding. So this binding 0 here, that's for the uniform buffer. And it's binding in from the same buffer that we're using. That's just a terminology. Which version of this we're using. Just to tell it which interpreter to use. Okay. So there isn't one for the actual uniform, because that binds backwards to this handle here. So that's what that binding equals 0. that has to match this because we're using only one buffer. We're not using two buffers. If we're using a second buffer, we would have two of these. We would have the vertex buffer and we would have the uniform buffer binding handle, which would be one. Probably. Possibly. Don't know. Didn't do it that way. So we now have shaders. Okay. So that's the shader location for Vertex. Position location. The color will be shader color location. So location in shader. Yeah, I think we can understand that now. Is this the same here? It is. Okay. And this is the offset, which is 4 floats. So this comes under the buffer. It isn't though, is it? Yeah, it is. It's to do with buffers. Okay. It's how to define them. That's the problem. So I think we'll be looking at something like vertex buffer. And we're looking at color offset. And that equals 4 floats. Alright, I think we're getting somewhere with all of these magic numbers. And it wants it in bytes, so yeah. We've still got a 0 here. So that's the offset for the vertex. The position offset. Okay, so there's another one here. It's 2. So it's vertex buffer, and that's position. Offset. And that of course equals 0 because it's at the beginning of the buffer. It's the first part of the information that we send in. And that can go in here. That's what you mean. And that's now 0. Good. So we're not changing the constants. All we're doing is defining what they are. We may have to change them in future, obviously. We may have to make them into variables. Even more interesting. Hello there, a nerdist. Good to see you joining in. I'm working through magic numbers in a code base. Today's all about magic numbers and trying to make sense of them. Alright, we've got 0 flags. This is for the vertex input info. Why would that be any different from the other flags that we've got? That's your memory mapping flags, and that's coming from the memory. VK memory map flags. Okay. So what's this one? We're just setting the flags for vertex input information. Oh dear. Well. I wonder what flags are available to us. I don't know. Am I supposed to know? I could always look them up. Vertex binding description count 1. There's only one description. Vertex attribute description count is 2 because there's 2 items in our vertex attribute. Oh, that's a variable. I don't intend to make the other 2 variable, but I do want one on that third. If I add textures, that's going to become 3. That's the number of vertex attributes. I need that one. I know I'm going to need that one in future, so I'm going to mark that one. These 2, I don't know what flags are available, don't really care right now. And oh, wow, we got a follow. Thank you, a nerdist. That's really kind of you. Cheers, dude. Or dudette, depending. I think I just made a word up there. You see, if we had 2 different buffers, then the vertex binding description count would have been 2. That's the number of buffers. I'm only using 1, and I'm probably only ever going to use 1. But the attributes will change over time as lighting comes in and things like that. Especially for textures, bump maps, PBR lighting, that kind of thing. You know, there's quite a few different things that can happen to this as we develop it over time. If we develop it over time. So the first 2 constants agree with future plans. That last one doesn't. So this is the number of vertex attributes. Okay. And that goes with this part. The number of vertex attributes. One attribute is position. One attribute is color. Two. So it's literally these here. This looks like an enumeration to me. That looks like an enum. Don't you think? Starting to see a pattern. That does look like an enum to me. Possible enum. Just pop that there. That might help us out later on to make it all automatic. You got to automate all of these numbers, by the way. Okay, we're up to here. Just pop you in there so we can see it. Put it on its own line. Not happy about these two being there. But I have no reason to change them. Yet. I bet in the future those flags will change. I'm just wondering, in the future, will I use more buffers? We could have a num buffers used. I've got to decide now whether to change these or not. And the answer is, yeah, we've got to change them. Okay. We'll change them. Don't be lazy. Do it properly. Alright, that is the number of vertex buffers used. Okay. I'm trying to put them in some kind of order as I go. Num vertex buffers used equals 1. And we also need to define the vertex buffer flags. So hash define vertex. It's going to be buffer 1 flags, I guess. It's really, really difficult to tell what is good and what is bad with that. Can't see it. That's the best I can do, I think, for that. Is this fully filled in then? I don't know. God, I'm going to have to look all of these up, aren't I? Pass 2. Yeah, I've already done it here. Taken the mem set out. Desk pool info, pool size count 1. Descriptor pool size. That only changes if current frame. Yeah. Why would that change? Obviously, you want a bigger pool of descriptions. So it's descriptor set pool size. We could obviously have more. We could just guess. I think you need 1 for each description, maybe. We've got 1 description here. 2 descriptions here. But this is a set of descriptions, so it's per set. This is your VBO. This is your vertex buffer object, isn't it? Bet you any money it is. I think we found our VBO, folks, from OpenGL. Let's have a look at you. Oh, we have a max sets. Hold on a minute. These aren't in the same order. So pointer to pool sizes. That's this one here. Pointer to an array of descriptor pool size structures, each containing a descriptor type and the number of descriptors of that type to be allocated in the pool. It's your VBO. So we could have one descriptor. Where's our max concurrent frame count? Okay, so we can only have one descriptor per frame. That's not correct. I'm going to have to fix this lighter, it's bothering me whilst I think about this one. Oh dear. Ooh. Well, we've got a good one here. That is dependent on the number of descriptors that we make. It also means that we can choose between different descriptions. So we could describe one model to be rendered in one way and another model to be rendered in a different way, using different shaders, for instance. That could be a bit awkward. That's what you use a VBO for in OpenGL. And yes, we only have one. We'll have one model being displayed. This is an example, it's not a working environment. That could change very rapidly. So we do need it. It is variable. Ah dear. What we're going to call it? Descriptor set pool size. I think I'll take that off then. Okay. Where does that fit in with all of this lot? Doesn't really, does it? It looks like we've got a new area. You notice I always spell it the wrong way? Dyslexia. For the win. Size. We'll make that 1. I always misspell it the same way though. And we are getting quite well into this. That equals 1. Good. Got past that one now. Oh, we've got another binding. But this is the descriptor set layout binding. Yeah, is it a different bind or is it the same bind? Is it related or not? Binding is the binding number of this entry and corresponds to a resource of the same binding number in the shader stages. Thank you. This is the uniform buffer binding. This is this, which is the same as and relates to the other one. The bet this is the number. If we can find it. What's this mean here? Put a comma in and find out. Flags? No, can't be flags. Descriptor count. So we've got binding, type, count, descriptor count. That's not a descriptor count, that's a descriptor set count, isn't it? Isn't it this one? Not sure. Descriptor count is the number of descriptors contained in the binding, accessed in a shader as an array, except if descriptor type. This is for uniforms. There's only one. So this is the number of uniforms. Uniform descriptors. Okay. Alright, we'll keep an error there. It's easy to find then. This is to do with our shader. So we'll pop it in there. That's what that relates to. Okay. And that's the simplest way I can put it without it becoming a total sentence, I suppose. Because that's not quite right, is it? It's descriptors. Yeah, we'll take it out of there. We'll put it with this lot. We'll put descriptors. Yeah, that's more accurate. Okay, I'll go with that. Oh God, what have we got here? Descriptor set layout create info. Is this another one? No, that's the binding. The information, VK structure type, descriptor set layout create info. Uniform buffer. I thought we'd already done one of these. No, that's just a pool. Pool. Layout. Layout for the uniform buffer. And layout for the normal stuff. Okay. We've got S-type P flags, binding count, and bindings. Great. Why does this have to be so weird? It's not weird, it's simple. And that's the whole point to it. So we have a constant void star next. Yeah, that's a null pointer. Yeah. Then we have the flags. Descriptor set layout flags. and binding count. Options for the descriptor, yeah. Is the number of elements in P bindings. Really? P bindings as, oh right, see here. Number of elements in layout binding. So we're still on this uniform buffer. Storage uniform buffer. Right, because it isn't a uniform. We've got to put a 0 in because it isn't a uniform buffer. It's storage, I suppose, of a kind. Yeah, right, all the different rules for putting flags in. Do we have a correlation here? I've got a horrible feeling that layout binding can be an array. And what it's looking for here is the number of layout bindings we have placed in that array. And if we increase the number of uniforms, we I wonder if the binding count goes up. Are they a direct correlation? Or are they independent? Don't know. The variable, obviously. Okay. So this is descriptor sets again. descriptor set. I've got two of these. The first one is layout flags and the other one is binding count. And that is binding count. Okay. It's not looking bad so far. There seems to be an awful lot of these numbers lying around. Right, we don't need these descriptions anymore, they're no longer valid. Excellent. I can't see, I can see a correlation between number of uniforms and the binding count, but I can't confirm that it's real. Not from the information they give here anyway. Great documentation. I mean, the documentation is all we have to go on, so we have to use that. And it doesn't seem to make a correlation or an inference, so there's nothing we can do about that. Okay, we've got another one here. You can see how difficult this is now. And why whoever gave us the at QT, whoever gave us the example, used magic numbers, because I don't think that they were quite prepared for this example to ever be used properly. And it doesn't look as though they were. Descriptor set count. Determines the number of descriptor sets to be allocated. You can have more than one descriptor set, my god. Allocated from the pool. So this is descriptor set allocation. So it's another one of these things here. So it's a descriptor set, num well, it's allocation what? Num to be allocated. There you go. 1. There you go. Self-explanatory now, isn't it? See, descriptor set I. There's I think that's a bit of a giveaway. The address of the descriptors set depending on current frame count. Okay. La 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 la. Oh look, got rid of another mem set here. La 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 la. That's what that means there. Mem set. Did you not know that the brackets in a scope run a program? Yep, that's true. Descriptor count. So this is when we're writing. I've given up trying to work them out totally, so now what I'm going to do is keep looking them up. Destination, descriptor count. Is the number of descriptors to update. Number to update, okay. You'll see that all of these follow on from each other. Descriptor this isn't set, is it, anymore? We seem to have gone back to the one above. So, num to update 1. Number of descriptors to update. If the descriptor binding identified by dset and dset binding has a descriptor of inline uniform block, then descriptor count specifies the number of bytes to update. Otherwise, is one of them. But we're not using inline, so it's one of these. Could mean various things. Definitely a variable. There we go. You're now 1. Ooh. I wasn't expecting that. Array element is the starting element in that array. Okay, well that's 0. Binding is the descriptor binding within that set. I think those are the starting positions. Look like it. want to change those. Will I ever want to change them? Will these ever change? The answer is yeah, the variables, of course they will. We could have a big array of these things, and the binding might not be at 0. Or it might not be the 0th binding we want. Oh. Right. So, what does those zeros actually mean? That's a better way of looking at this. So, it's the first descriptor array element. Or descriptor array element first. And descriptor binding first. Okay, got you. La, 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 la. There's a lot of this description thingy. The reason there's so much description stuff is because the GPU doesn't know what your data is. You have to describe it. Descriptor. Element. That'll never change. That's now a constant. That's a proper constant. Descript. Binding. That's first. That's now a constant. Good. First. Descriptor binding first. So now we can look these two. We can find these two easier now. Oh God. Update descriptor sets. A device. Number descriptors. Num to right is the same to update, isn't it? Surely. If you have two, you'd write two, wouldn't you? It's the right count, is the number of elements in the P descriptor rights array. Okay. So it's the number of these. Not necessarily the number of that. So it isn't that, is what it's trying to say there. It's the actual number of these structures that we've got. P descriptor rights array. I think it's this one here. Whatever we'll put in the next line there, P descriptor rights. Desk right. Desk right. Yes, it is. It's the number of these. So it's the number of descriptor sets to write. Is the full. Keep it under descriptor. Num sets to write. And we've only got one. Okay, and descriptor write, and then descriptor copy count is the number of elements in the descriptor copies array. We don't have a descriptors copy array, so we're not using that at this point in time. I don't know if we'll be using it in the future. I don't know what it's used for. Instancing? Is that instancing? Creating multiple copies so that we can instance the model multiple times. Changing the location of the model. Drawing a forest. I think it is. Need to know more. Don't know at the moment. That's all I can think of putting for that. A question. Can't decide because I don't know. We can mark it as a to-do. I'll put my name on it. Something I need to know about. I've not looked up instancing yet. for obvious reasons. I haven't got that far. Right, looking good. We've got another mem set here. Goodbye. This looks okay, can't read it all. Let's just have a quick look through. No, nothing's there. Pipeline layout. Another mem set. Really? Push constant range count. Dee-li-dee-dee-dee-dee-dee. Okay, where did you come from? P next. This doesn't look right. That's not what I asked for. That one there. Oh. What's going on here? Is this new? Okay, let's pop over to you. VK pipeline. There we go. Oh. Push constant range count equals 0. What does that mean? No, it's 2. It's not 3. No idea. Set layout count. We can do that. To be allocated. We don't have any layout stuff here. We have descriptors. Ooh. Okay, so we haven't met layout yet. I don't think I can use any of these for layouts because they're not exactly designed for layouts, are they? My God, we've done a lot of magic numbers. I think we need a new category here. It says here num descriptor sets. Well, I think that gives it away. think it's this one here. It's that one. That's the number of descriptor sets we're using. So we might be able to change that to descriptor num sets to use rather than write. Yeah. That might be a better description of it. Okay. Shader stage is 2. I think we'll keep with 2. And we've got a 0 in it. You creep. What's 0 mean? Got it twice. Thanks. La 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 la. This is the part of programming that people don't do. Why? Because they can't be bothered. I've spent my life doing this because other people don't. Shader stage create flags. So that's flags, is it? Null pointer. It's a bit mask, specifying how the pipeline shader stage will be generated. So shader create flags. Depends on how you're going to create them. Well, I'm happy in the way that we are creating them. Those aren't going to change. Okay. Stage count 2. Yep, that's not going to change. Oh, wait a minute. Ah, that is variable because, yeah. Okay, we'll give one for that. I can go with the shader stuff. Yeah, that does. We might do compute shaders or geometry shaders later on, I don't know. But we do have that possibility. And that would then become very, very important. Pipeline cache, pipeline. Shaders, the different modules, yep, the pipeline. I think that's what you mean. Pipeline info. Got a problem with you, haven't I? Yeah. You're different. Why are you different? Graphics pipeline, create info, go. Yeah, that's correct. It's asking how many shaders are you using, and also for the stages, which are these two structures here. And that's an array. So that makes sense. Okay. Input assembly state. Information. What the blooming heck? Pretty detailed, isn't it? This is the kind of thing that I actually enjoy doing, by the way. We have some flags here. Is reserved for future use. There we go, done that one. Okay, we've got another one here. I like those easy ones, because there's an answer to them. Create info. And we've got a null pointer followed by flags again. Reserved for future use. Viewport count and scissor count I'm leaving as 1. I'm not doing multiple viewports. I wonder what this one's going to say about the flags. Reserved for future use. I like these. These ones are easy. Depth bias constant factor. Float. Constant depth value added to each fragment. Okay, I don't think I'll be changing those. Line width I'm not going to be changing. Those are defaults. Let's name them that, shall we? Those are the defaults I'm going to use for those anyway, so there's no point in changing them. Okay. We've got another. Well, this is going better now. I think we already know what the answer is, but we still have to look it up. How the pipeline will be generated. Ah, you see. Make sure I'm on the right thing. No, I'm not. That's graphics pipeline. Is reserved for future use. Okay. Min sample shading. Float. Specifies a minimum fraction of sample shading if sample shading enabled is true. Okay. Sample shading enable which it doesn't, so to that one. I like the flags. The flag situation on Vulcan is quite nice. Basically, they're giving themselves future options. Am I on the right one? We are. Okay. At this point, I do need a coffee. So, we're up to line 768. We have removed an awful lot of magic numbers from this pretty horrendous piece of code. Let's be honest, it's pretty horrendous. Let's not beat about the bush. The original code was written in such a fashion that it wasn't exactly correct. It was good example code, it just, well, cut a few corners. Shall we say. Corners which we now have to uncut. Because in the final code, we're not allowed to cut corners. And this still has corner cutting in it. Still. There's a mem set there. Thank you. And cutting corners instead of letting the compiler do things for you. Mem sets. Why on earth would you have that there? Unless it's to remind you to put in free. You see, if you do it using the scope method, the scope will also free. The end scope of your program will also free that information. If you use the memset command, it won't. You have to free it yourself. Oh, that's the theory. The compiler usually just removes the memset and puts the brackets in, to save you the embarrassment of what you've just done. Right, I do need a bio, I do need a coffee. Let's get this set up. Let's try here. Let's get to the right place. Yeah, I think that says it all. I'm going to just go and put the kettle on. Unfortunately, the kettle's downstairs, isn't it? And I'm not. What have I got here? Alright, what's this stuff like? A raspberry energy drink. Oh god, I'm going to get drunk off that. Alright. Fair enough. Let's get back to this. Stuff the coffee. I've got energy drink. That'll get me through the next hour, if nothing else. I do want to finish this today. So we've got a P next, and then we've got some flags. Specifying additional depth stencil state information. Might as well mark the line. Minimum max. Why do we need a minimum max? Minimum depth bound used by the depth bounds test. Maximum. Well, it's not enabled. Okay. Compare mask. Right mask. No, I'm not changing anything in there yet. I would need to know a lot more about stencils before I could do anything with that lot. Dooby-dooby-dum-dum. I don't know enough about this law either. Yeah, I understand what that is, but I'm not going to be touching that. I'll be setting up blending separately. Really should have these in different files. It's starting to look that way. Try and catch as many of these as I go through. Don't think there's anything left here. Oh wait, whoa, we've got an error. Error equals. No idea what that means. I think it just means the first error. Possibly. Or the last error, I don't know. Not going to pretend to know these things. Camera locations, these are all variables that I've put in to make the scene work. Nothing to do with pass 1, everything to do with pass 2. It's looking good now. Absolutely looking good now. Wonder what uses 3. Interesting. Another error, but this time with a 0 in it instead of a 1. Interesting. Okay, everything. We've got one here. It's that magic number 16. We know what that is. Uniform location. Yep, we're sending a matrix through. Nothing else on there. Oh God. What on earth is this? Oh my God. What does that mean? I mean, I could take a guess. VK command bind descriptor sets. Well, I know what it's doing, it's binding our sets, but we've got pipeline layout, first set, descriptor sets, dynamic offset, offset count, which we're not using. So this is descriptor sets. I'll just put a comma there. Oh, we're near the bottom. Way! Num sets to use. Well, I know where that one's going. That's that one. One. And the first set is always going to be at 0, isn't it? Depends. Is that correct? I think it is. But those don't match each other, do they? So I think it's as close as I can approximate with the numbers that I've got. Alright, don't really care about that. And we've got another one here with a 0 and a 1 in it. Magic numbers. Do 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 do. First binding and binding count. First binding. I'm looking for something with binding in it. There it is. Where were we? So first binding is that. Binding count is the number of buffers. I think that's the only thing I can really come up with for that one. Yep. Yeah, okay, I can accept that. Yeah, I can accept that. Set viewport. What? What's this? First viewport 0, viewport count. Okay. Okay, I'll leave that as a note. Scissors, not bothered about. Again, I think this is the same. Looks very much the same, doesn't it? Okay. First scissor and scissor count. There we go. So it wasn't the same. We come to the command, the draw. Okay, so command buffer, vertex count. Okay. That was badly done. There we go. What comes after vertex count? Instance count. Well, that's instancing for you. First vertex, first instance. Information that we might need in the future. Done, done, done. FPS counter done. Wow, we did a lot. I think we might have... don't like the num buffers thingy here. That's the number used. I think I prefer it like that. Might do better. It's a better description of what I want anyway. I don't know about all this other stuff. But that's the actual renderer. Good. Done. And the program works. Amazing. Yep, that's all correct. That's correct. Should be 93. Thank you. Everything destroys. Good. Resources released. Good. Return. Perfect. So these were all the magic numbers here. It's an awful lot, isn't it? There you go. Full list of all the magic numbers used in this program. Well, that's interesting. Why were so many magic numbers used? Because magic numbers are only used to force a program to work. All of these have to be changed into variables to make the program useful. The program is only an example at this stage, and this proves it. It's an example because it can only be used with these magic numbers. If we change any one of these numbers, the program should stop working. But maybe we don't just want to display one model. In this case, we do. But if we want this rendering to go into, let's say, Midnight, for the rendering system in Midnight instead of the text render. We've set up a way in which we can load our models very easily. This program renders, and using the example given by Qt, this is what we find out. That the example will only work under this state. Is an enum. Why didn't the example use an enum? Because it was simpler just to put the numbers in. if I add layers? Well, the first thing I'd have to do is